everyone. Today we are going to be talking about structural theory, simple Lewis structures, and formal charge. So, compounds with the same molecular formula but different structures are constitutional isomers. So here we have dimethyl ether with a boiling point of negative 23 degrees Celsius and ethanol with a much higher boiling point of 78.4 degrees Celsius. So the different arrangement of atoms means the connectivity is different, meaning there's different constitution, meaning different properties. Here we can see hydrogen bonding. Now that is going to be responsible for that higher boiling point. Whereas over here, oxygen is not bound to a hydrogen. Now, to get hydrogen bonding, it is a hydrogen atom bonded to nitrogen, oxygen, or fluorine. Now, atoms that are most commonly bonded to carbon include nitrogen, oxygen, hydrogen, and the halides fluorine, chlorine, bromine, and iodine. So, with some exceptions, each element generally forms a specific number of bonds with other atoms. For example, we have tetravalent with 4 bonds, trivalent having 3 bonds, divalent with 2 bonds, and monovalent with 1 bond. An X can be fluorine, chlorine, bromine, or iodine. So moving on to Lewis structures. For a simple Lewis structure, we are going to draw individual atoms using dots to represent valence electrons, putting the atoms together so that they share pairs of electrons to make complete octets. Now, what is an octet? Well, for example, if we have neon, neon is in the farthest row. Neon has a full octet with 8 electrons. So its valence shell is full. Now, let's look at NH3. So nitrogen has 1, 2, 3, 4, 5 electrons. It has 3 lone pairs. Hydrogen has 1 valence electron. And what we're going to do with our Lewis structure is we're kind of just going to mesh them together in a sense. So we'll take our nitrogen and we'll add all the valence electrons. And then we're going to add our hydrogen. Now, we'll switch color for this so it's easier to conceptualize. And you see they kind of fit together in a sense, which will lead to a full octet on the nitrogen. It's taking or else sharing the electrons with the nitrogen and hydrogen. Now, I want you to draw a Lewis structure for CH2O. Now, you can pause the video here, or you can watch along as I solve it with you. So we know hydrogen has one lone pair. So we're going to draw two of those. Oxygen has 1, 2, 3, 4, 5, 6. And carbon has 4. So carbon likes to make 4 bonds, but in this case, how it's going to be grouped together is going to be carbon 1, hydrogen 1. Now those two will come together to form that special little bond, single pair. And for the oxygen, oxygen likes to have 2 bonds. So carbon is going to take its 2 electrons together and go to the oxygen. And so that is going to form a double bond as well. So here, everything is happy. Hydrogen has its 1, carbon has its 4, and oxygen has 6 electrons because we kind of slice it in half. Now, the formal charge is explained just in that way, right? What would happen if we didn't have the double bond there? Let's say we had another hydrogen. Well, carbon would bond to that other hydrogen, and oxygen would have 1, 2, 3, 4, 5, 6 pairs of electrons. So if we cut it over here, it would be 1, 2, 3, 4, 5, 6, 7. And that would give it a negative charge. So this is why it is very important to keep track of your periodic table, see which column it is in so you can know, oh, this is what we're looking for. This is how many valence electrons it will need.